Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, from past 3 days we have been discussing about the chapter electricity. So let us go for continuing this. Before that, just we shall recall some important points what we learned in our yesterday's class. The very first point, could you tell what happens when a charged particle is kept in an electric field? Yes, you are right, it experiences the mechanical force. Then to make it experience a mechanical force, the energy is required, hence work has to be done. Then what do you call the work done in bringing a unit positive charge from infinity to the given point in an electric field? This is called electric potential, and electric potential is denoted by the symbol V, and the formula is V equal to W by Q, and its SI unit is volt. Symbolic representation V. The word volt has been taken from the name of a scientist is Alessandro Volta. Then we are also very familiar with one of the word, that is voltage is nothing but potential difference. Then what is potential difference? It is the work done in moving a unit positive charge from one point to another point in an electric field is called potential difference. It is also denoted by the symbol V. Formula is same, V equal to W by Q, and the SI unit is also same, volt. To measure electric potential or potential difference, we go for using a device. What it is? It is voltmeter. Voltmeter is a device used to measure the potential difference between the ends of a conductor. Then this voltmeter is always connected in parallel in the circuit, and reason, let me tell you that later. And the circuit symbol of voltmeter is like this, encircled V with the terminals plus and minus. If the current has to flow in the circuit or in the conductor, then it has to maintain the potential difference. For that purpose, which electrical component is used? Yes, you are right, it is again electric cell or battery. Then what do you call the minimum energy required to maintain the constant potential difference across the ends of a conductor? This is called electromotive force. That is, in short, it is EMF. The source of EMF is a cell or battery. In addition with these, we have also solved some of the problems as well. And one more important information regarding a source of EMF, that is cell. Even though the battery or cell is not connected to free ends of a wire, it maintains the potential difference. How? Because inside the cell, due to chemical action, it generates the potential difference. Got it? So, and also one more important information, that is about electric circuit. Even we have got some little bit information about it. We have made a simple circuit by using the electrical components, that is an electric bulb, then a cell, then a switch. In addition to that, we have used one more, that is wire. This is how we have arranged. When we press the key, then the current starts flowing in the circuit from positive terminal to negative terminal. So this is the path in which the current flows, and this path is known as electric circuit. Clearly, it can be defined like this. The closed and continuous path in which the current flows is called electric circuit. Clear? But how these electrical components are connected? Yes, to indicate that we have a diagram, this is called circuit diagram. Then what is circuit diagram? Observe it. Here we have used some of the circuit symbols for different electrical components. See that this is the symbol of an electric bulb, it is the symbol of a cell, and this is a symbol of switch. It is the diagram which indicates how different electrical components have been connected or have been arranged corresponding to the circuit symbols of the electrical components is known as circuit diagram. Clear? So to make a circuit diagram, we go for using different electrical components. So they have symbols as well. Here I have made a chart which represents the electrical components with their circuit symbols. Let me show you one after the other. Just keep observing them. These are the circuit symbol. On the left side I have written the electrical components, on the right side their symbols. The very first one is, it is electric cell. We know that it is also called dry cell. It is a device which converts chemical energy into electrical energy. And this is the symbol. We have used the longer line to represent positive terminal, shorter line negative terminal. And second one, battery. Battery is also a device which converts chemical energy into electrical energy. But only the difference is, it's a combination of many cells. See that more than one cells. Here I have taken 3 cells. This is positive terminal, next negative terminal, and these cells are connected with a line. Third one, switch. There are 2 types. One is open switch and another one is closed. That means when it is open, no current flows in the circuit. And this is the symbol indicates the circuit is closed. In place of these switches, even we can go for using plug keys as well. To say that circuit is open, we can go for this symbol. And second one, plug key, it is closed. That means current is flowing. This is the symbol. To represent the conductor, we have used the symbol like this. Just you have to draw a line. And again, keep observing. And one more information, when you after watching this up to here, you have to pause the video and should copy this in your notebook. Next, we have some more electrical components. 8th one, wire joint. See that here the wire has been taken. At this point insulation is removed, then it is to be connected. This is wire joint. Here wire crossing without joining. In sometimes we will go for taking the wire one on the other, and to represent that, this is the symbol. We have drawn a line and another line is drawn with a curve. Next, electric bulb. We know that energy conversion that takes place in electric bulb, it is electrical energy into heat energy, then light energy. These are the symbols. You can go for either this or this symbol to represent electric bulb. Then resistor, which will be discussed in the later part, there is just zigzag lines. And variable resistance, that is obstruction. If it is changing, it can be represented like this. Zigzag line with an arrow mark over that. Next, to vary the resistance in the circuit without changing the voltage, we go for using a device. This is called rheostat, and this is the circuit symbol for a rheostat. Zigzag line, then arrow mark is shown, L-shaped arrow mark is shown. We are very familiar with the last 3 devices. Ammeter, used for measuring amount of electric current flowing in the conductor. Then we have written A, it is to be encircled. Then draw the line and show the terminals. Here voltmeter, device used to measure electric potential or potential difference. Encircled V with terminals. Galvanometer, it is a current detecting device. or when feeble amount of, very small amount of current is flowing in the conductor, under such condition, if it is not possible to use ammeter, then to detect the current flowing, we can go for using galvanometer. It is encircled G with terminals. See, now you have to pause the video and should copy all these electrical components. Next, we have one more chart. In this also, I have written circuit symbols of some more electrical components. You are very familiar with this device used in the electric circuit, that is electric fuse. It is a protective, it acts as a protective device and it breaks the electric circuit when excess amount of electric current flows in that. And this is the symbol. We have put a box, then drawn two lines in between. Just an arc is drawn. Next, AC, that means alternating current, which we are using in our houses, schools, industries, hospitals and all. This is alternating current to represent that. Just we have sleeping 2 is written, then it is encircled. Direct current, that is whatever the simple circuit we have made using the cell, that is an example for direct current. And this is the symbol. Just put a line, hyphen and encircle it. And the source of voltage, nothing but it is cell. And to represent milliammeter, we have written MA, milliamps. In the ammeter is used and current is measured in terms of milliamps. It has been mentioned like this. Transformer, you are very familiar with this word. You might have seen on the roadside there will be two poles will be there, and in between them a box like a structure will be placed. Why? To increase or decrease the voltage of alternating current. So that is called transformer. Is a device used for increasing or decreasing the voltage of alternating current is transformer, and this is the symbol of transformer. And one more, tapping key. Just on tapping, the circuit will be closed, current flows. If it is kept open, no current flows in that. Then resistance box, on that box particular resistance will be mentioned, and to represent that we can draw like this, just a box like structure. In that we have written RB, resistance box. So these are the different electrical components with their circuit symbols. Now we will move on to the next part of this chapter. Dear students, one simple question will be asked to you. The question is whether same amount of current will flow in all the electrical components what we have come across so far. Yes, what do you say? So you may be thinking that just let us go for answering this question with a simple activity. I am going to explain that activity with this chart. Just observe it. Here, to measure amount of electric current flowing in the component or the conductor, we go for using a device. The device is ammeter. Here I have made a simple circuit. You can observe this one. See that. Here X and Y, it is a place to connect the electrical component. Now we have used wire, then here ammeter is connected, then battery is there, combination of 4 cells, and here is the switch. And so switch, it should be opened because circuit is not closed. Now here I am going to use different electrical components. First one is nichrome. Nichrome, we know that it is an alloy which is made up of 4 different metals. One is nickel, second one is chromium, third one is manganese, and fourth one is iron. It's an alloy. Here what you will do is you will connect this nichrome in the place XY and record the amount of electric current flowing through that using the device called ammeter. Similarly, then after that you off that by pressing the key, then remove it, again place another device. It is bulb and torch, and record the amount of current flowing in these materials, in these electrical components using ammeter. You will come to know that different amount of electric current flow through the different electrical components. Got it? Then you all may be thinking that why it happens so. The reason is some electrical components will give easy path for the flow of current, but some will try to resist the flow of current, like nitro. Now, what it is? To know that what it is, let us understand the arrangement of atoms present in the conductor. Just here also I will go for showing that with a chart. Look here. Here I have taken a conductor, and enlarged part of conductor is taken, and in that plenty of atoms will be there. Plenty of atoms will be there, and we know that in those atoms there are some electrons which are very loosely bound to the atom, or they are free from the atom. Such electrons are called delocalized electrons. As the atoms lose the electrons, we can call such atoms as ions, and these are called delocalized electrons. They find it very free to move, but at the same time you can also come to know that when they are moving, they oftenly collide with the atoms or ions. So this is the obstruction for the flow of electrons. So this obstruction, it is a common property of all the conductor, and we call this property as electric resistance. Electric resistance means the property of a conductor which obstructs the flow of electric current through it is known as electric resistance. So let me go for writing the definition of electric resistance. Observe, here I have written the definition of electric resistance. It is the property of a conductor due to which it obstructs the flow of electric charges through it is known as electric resistance and is denoted by the symbol R. And this electric resistance has some of the important properties. Now let me go for telling you one after the other. Here again I go for using the chart. You hope that just you have seen it. Here the movement of the electrons in the conductor. So here there is obstruction for the movement of electrons, which we call electric resistance. What happens to the electric current as electric resistance increases? If electric resistance increases, then current flowing through in that circuit, it decreases, because as resistance is increasing means there will be more obstruction for the flow of electron, therefore current decreases. Similarly, as electric resistance decreases, then the current increases. Now one more important thing, see that you may go for taking any electric circuit, then in that a battery or cell is used and it has some voltage. Call that voltage of the battery as around 3 volts, and we have a device to measure the potential difference between the ends of a conductor, or at any 2 points in the circuit. You may connect anywhere else and measure this. You can come to know that so the potential difference between any 2 points in the circuit is less than the source of EMF. Why? Again the same reason, it is due to the electric resistance. So hence we can write that the potential difference between 2 points in the circuit, 2 points, is less than EMF. And one more important property. Again, see that as the electrons are moving in the conductor, they oftenly collide with the atoms. Due to the friction, heat is produced. That is why sometimes in case of DC, when you just go for touching the wire, you feel warm. It is because of this reason. Hence, we can say that electric resistance causes heating effect. It causes heating effect. Now, based on its one of the property, we can classify the material into different types as good conductor, that is which offers less electric resistance. Then if it is appreciable, if a material offers appreciable resistance, then we can say that it is also good conductor. If it offers more electric resistance, then it is bad conductor or poor conductor. If it offers zero electric resistance, then we call it as superconductor. So do remember, superconductor, they offer zero electric resistance. How? Here, when the whatever the metals will be there, when their temperature is brought to, when the temperature is decreased to certain particular temperature, then they offer zero electric resistance. And in case of superconductor, there will be no obstruction, one thing. Second thing is no heat is produced. Got it? So conductors, then good conductors, then bad conductors are insulators, then superconductors. So these are the different materials which can be defined based on the electric resistance. Now this electric resistance depends on some of the factors. Now let us go for learning what are these factors. You may write the side heading, factors on which electric current depends, or factors which affect the electric resistance. Right? Factors on which electric current, electric resistance depends. Let me tell you these one after the other. Dear students, here to understand the factors on which electric resistance depends, here I have drawn a simple circuit diagram. Just observe, we have used a battery, ammeter, and XY is an electrical component. That XY is nichrome. As it is an alloy, it is a combination of nickel, chromium, manganese and iron. At present, when nichrome is connected to the 2 points X and Y, then you take the ammeter reading, assume that it is 3 amps. Now, in the second case, you are going to double the length of the nichrome. Then as length increases, now let us, the ammeter reading, assume that it is 1.5 A, that is 1.5 ampere. You may be thinking that how this is possible. Let me go for explaining. Here, as the length of the conductor increases, the electric resistance is decreasing. Do you know the reason? Here I'll go for explaining. Look here there will be number of atoms. It's a conductor. Then here these are the electrons, they flow in the conductor, they collide with the atoms. Obviously there will be obstruction for the flow of electrons, hence resistance is existed. As the length increases, this obstruction for the flow of electrons will go on increasing. Hence we can say that the first factor on which electric resistance depends is length of a conductor. Followed. Now, how as the length increases, then resistance also increases. As length decreases, resistance also decreases. We can write length. Resistance is directly proportional to length. Now, similarly, here, in the third case, we have taken again nichrome, but the thickness is different. Thickness is more. Then what will be? It will, what will be the ammeter reading? Here I'll write 4 amps. That means as the thickness increases, the flow of current is increasing. Flow of current is increasing, that means electric resistance is decreasing. As the thickness increases, then the electric resistance decreases. How? Imagine that there are two pipes. One is PVC pipe of more diameter and another one is ordinary tap pipe. It has a less diameter. You go for taking some marbles. You go for leave these marbles one after the other. In which of these two marbles find it difficult to move? In case of first one, that is the tap pipe. Why? There will, as the diameter is less, so they get less space for the movement. Similarly, here also, as the thickness of the conductor increases, electrons will get more space for their movement. Hence, electric resistance decreases. So this is second one. That is, thickness is nothing but area of cross section of a conductor. Area of cross section of conductor. So area, let us denote this by A. As the area increases, that means as the thickness increases, resistance decreases. As the thickness decreases, resistance increases. We can write it is inversely proportional. R is inversely proportional to A. Clear? Now, third one. In third case, I am going to take some other component. Instead of nichrome, I am going to take copper. I am comparing the nichrome and copper. The arrangement of atoms in both of these is different. Among these two, which one will allow the electrons to flow easily? Yes, you are right. It is in case of copper. As electrons can flow easily in case of copper, the current will be more. I just write 6 amps. Then as the current is more means, what about the resistance? There will be less resistance. So similarly, you may go for taking the material like silver. Silver still it offers less resistance, whereas in case of iron it offers more electric resistance. So arrangement of atoms is different in different metals. Hence we can say that electric resistance depends on another factor, that is nature of material of the conductor. Nature of material of the conductor. Now, one more important point. Suppose a conductor is there, in that many atoms will be there. We all know that atoms, they won't move, but they possess the motion called chaotic motion. That means the these atoms will be rotating in their position or they will be vibrating like this. Now, if the temperature of the conductor increases, what will happen? So, these will start vibrating more and more. Here, the electrons will be flowing. As they vibrate more and more, oftenly they collide with the atoms. These electrons often will collide with the atoms. Due to this, resistance increases. Got it? So, temperature is another factor on which electric resistance depends. So, temperature of conductor. Temperature of conductor. So, I'll write it as T. How? As the temperature increases, resistance also increases. As the temperature decreases, resistance decreases. Here I'll write R is directly proportional to T. These are the 4 important factors on which electric resistance depends. Please do remember. First one is length of the conductor. Second one, area of cross section of the conductor. Third one, nature of material of the conductor. And fourth one is temperature of a conductor. So, when you are writing this, you have to pause the video, then please go for copy. Clear? So, now we are moving to another part of this chapter. This is also very important in the examination point of view. Now, let me go for explaining it. Here, we are very familiar with potential difference. The work done in moving a unit positive charge from one point to another point in an electric field is called potential difference, and its SI unit is volt. Then even in the very first class we have learned about a current. What is current? The rate of flow of electric charges is called current. The rate of flow of electric charges is current. The formula is I equal to Q by T. Clear? Now, is there any relationship between current and potential difference? Yeah, we say that if the current has to flow in the conductor, then there must be potential difference. Hence, the relationship is there between current and potential difference, and this was explained by a German physicist is George Simon Ohm. Ohm. And he has made a law. That law is called Ohm's law. Now let us go for learning this Ohm's law. Before that, first let us come to know what is the relationship between V and I, voltage and current, with a simple activity. Now let me go for explaining that. I hope that you all have copied this. Yes, dear students, here I have drawn a circuit diagram which can be used to verify Ohm's law, or which can be used to find out the relationship between potential difference and electric current. Here we have used different electrical components XY. It is a nichrome having some electric resistance. Then here V is voltmeter. You just observe, in the beginning only I told you that voltmeter is always connected in parallel in the circuit. Now let me give you the reason, because voltmeter, the very first reason is voltmeter has high electric resistance. When it is connected in series, it alters the flow of current in the circuit. Got it? This question can be asked in the examination. Why is voltmeter connected in the circuit in parallel? You have to write the reason, because it has high electric resistance, and second point, when it is connected in series, it changes the flow of current in the circuit. And third one, ammeter. Ammeter, it is connected in series in the circuit. The reason is it has low electric resistance, and when it is connected in series, it does not change the flow of current in the circuit. Clear? Now, and these are the cells. We are going to use different voltage of cells, each of just 1.5. This is 1.5, 1.5, 1.5, 1.5. So here we have drawn so because we are going to use them one after the other. Okay. Now before going to explain the procedure, first let me tell you how these different electrical components are arranged. Here we have the circuit diagram. Please observe this. In this diagram, let me tell you how to connect the electrical components. First, we have to take the nichrome XY. Take two copper wires, connect at X, and in that one wire should be connected to positive terminal of voltmeter, and another wire will be there. Connect that to positive terminal of a cell. Next, take two more copper wires, connect them at Y. Then in that one should be connected to negative terminal of voltmeter and another wire should be connected to positive terminal of ammeter. Next, take one wire, connect it to negative terminal of ammeter and other end should be connected to a terminal of a switch, and take one more wire and connect one of its ends to the other terminal of switch and another end should be connected to negative terminal of cell. Clear? This is how we have to connect the electrical components, and now the circuit is ready to verify Ohm's law or to know the difference relationship between potential difference and electric current. Very simple activity it is. As soon as the switch is on, then electric current start flowing from positive terminal to negative terminal of a cell. The first one is, what is its capacity? It is 1.5 volt. Immediately then go for ammeter and observe the reading and record it and write it in a table. Similarly, voltage. Here I have recorded in the first trial. In the first trial, we have used one cell and now current measuring in the ammeter it is showing that 3 amps and voltmeter it is showing that 1.5 volts. Next, switch off. Then go for connecting another one. It is also 1.5 volt. Then observe ammeter and voltmeter, take their readings. Those readings are written. Ammeter is showing 6 amps and voltmeter is showing 3 voltage. Next, again open the circuit, then connect one more cell. This is also of 1.5 volt. Now close the circuit by pressing the switch. Then again the current starts flowing, and observe ammeter and voltmeter, take the reading. That the reading is in the same. In third case, we have used 3 cells and ammeter reading is 9 amps, voltmeter reading is 4.5 volts. Next, one more, fourth trial. Again, switch off, then disconnect it, then connect one more cell. It is also of same voltage, 1.5 volt. Then close the circuit by pressing the key. Again take ammeter and voltmeter reading. In the fourth trial, you can come to know that current is 12 amps and voltage is 6 volts. Got it? So these are the readings. You can notice that as the current is increasing, what about the voltage? Voltage is also increasing, right? Then as the current decreases, voltage also decreases. You can also say like this, As the voltage increases, nothing but potential difference increases, current is also increasing. Hence, can we say that current is directly proportional to voltage? Yes. Or voltage is directly proportional to current? That is also right. Now, observe here. We are going to find out the relationship between V and I. V by I. V is nothing but potential difference is 1.5 volt in the first trial, and second current is 3 amps. 1.5 by 3, it is 1 by 2 is nothing but 0.5. In all these cases, 3 by 6, 0.5. 4.5 by 9, 0.5. 6 by 12, that is also 0.5. That means here we can say that the ratio of potential difference to the current is constant. I can write V by I is constant. Now, using these readings, let us go for drawing the graph of voltage and current. Here, you can observe that the it is the graph of voltage and current. Current is taken along x-axis, voltage is taken along y-axis. Even they can also be taken in reverse order, but as given in NCERT textbook only, I have taken I along x and V along y. And current, see that current 3 amp, 6 amp, 9 amp, 12 amp, it is like this. Therefore, I have written in x-axis 1 centimeter equal to 1 ampere. 1, 2, 3, 4, and it is continued. Then potential difference 1.5, 3, 4.5, it is in decimal form. Hence, I have taken 1 centimeter as 0.5 volt in y-axis. 0.5, 1, 1.5, 2, 2.5, like this. Then, when current is 3 amp, voltmeter potential difference is 1.5. That has been marked here. Current is 3, voltage is 1.5. When current is 6, voltage is 3. When current is 9, voltage is 4.5 volts. So then we have marked the point. On joining the line, you will get a straight line. So straight line that indicates the graph of VI is linear. That means the ratio of V by I is constant. Here I have written slope. What does it mean? Slope means it is the ratio of vertical distance and horizontal distance. Vertical distance is voltage and the horizontal distance is current. Clear? So now, here we have come to know that as the current increases, voltage also increases. Hence, can we write V is directly proportional to I? Certainly. Or as current increases, then voltage also increases. Hence, we can write I is directly proportional to V. Clear? Now, V is directly proportional to I. In reverse also it can be written. The reason is, suppose you will spend some amount to buy some mangoes. As the number of mangoes increases, the amount that is to be given also increases. As the amount that you have increases, the number of mangoes that you can buy also increases. Hence, V is directly proportional to I, or I is directly proportional to V. Both are same. Clear? Okay. Now, let us go for taking V is directly proportional to I. Then V is equal to I into R. What is I? To remove this proportional, I have assumed the proportionality constant. That the proportionality constant is R, because R is proportionality constant, and this R is called electric resistance. So V is equal to I into R. You can also solve R equal to V by I, or I is equal to V by R. Understood? So the relationship between potential difference and electric current, it is V by I is constant, and we have taken the constant as electric resistance. Now with this, let us go for stating Ohm's law. Ohm's law, it states that in any conductor at constant temperature, the potential difference between the ends of a conductor is directly proportional to the current flowing through it. This is the statement. So let me go for writing that. Please copy. So Ohm's law states that in any conductor at constant temperature, the potential difference between the ends of a conductor, is directly proportional to current flowing through it, electric current flowing through it. So this is the statement. You must learn this. It's very important one, and this law was given by George Simon Ohm. Okay, observe. Here I have written Ohm's law. Then, according to that Ohm's law, the mathematical expression has been written, that is V is directly proportional to I at constant temperature. As we know, it is proportional. To remove this proportional, we have assumed the proportionality constant, that is R. Hence, we can write V equal to I into R. So this is the formula used to find out voltage when you know current and electric resistance. Here there are three physical quantities. One is voltage, second one is current, and third one is resistance. So when you know any two quantities, you can go for finding the third quantity. So therefore I have written that in a simple way. Observe it. V equal to I into R. I have written in a triangle by making this as 3 parts. Now formula, see that first one, V equal to I into R, that has been written. Second one, suppose you want to find out current. Current equal to V by R, that has been written. Then if you want to find out the electric resistance, R equal to these two, V by I. Got it? It is better to remember this triangle in a simple way to remember these formula. Here, as I said, R is electric resistance. When you find out R, you will get V by I, where V is voltage and I is current. Hence, electric resistance formula can be written as it is equal to voltage by current. So, let me continue that here. It is R is equal to V by I. Then this electric resistance has the unit. We know what is that SI unit. We know that this relationship was given by George Simon Ohm. So to honor this scientist, a part of his name, that is ohm, is taken as the unit of electric resistance. Alright, ohm. And the symbolic representation is a Greek alphabet. This is omega, the symbol of ohm. Then the actual unit, when you go for using the formula, you get the actual unit. What is V? V is voltage. Voltage, its SI unit is volt. Then current, its SI unit is ampere. Hence we can write volt per ampere. And symbolically it can be written as V ampere inverse. Now in the examination, there is a chance of asking the question that define the SI unit of electric resistance, or define 1 ohm, or it can also be asked in another way as when do you say the resistance offered by a conductor is 1 ohm. So let me go for explaining that. 1 ohm, very important one. Here 1 ohm can be written by using the formula like this. 1 ohm is equal to 1 volt by 1 amp. That means the resistance offered by the circuit or a conductor is said to be 1 ohm when 1 ampere of electric current flows in the circuit such that the potential difference between the ends of a conductor is 1 volt. This is the definition. So now let me go for writing the definition. You should copy with me. Yes, just go through the definition of 1 ohm. Here I have written, the same thing should be copied. The resistance offered by a conductor is said to be 1 ohm when 1 ampere of electric current flows through a conductor in which the potential difference 2 points is 1 volt. So that is 1 ohm is equal to 1 volt by 1 amp. This can also be written in another way as the resistance offered by a conductor is said to be 1 ohm if 1 ampere of electric current flows through a conductor in which the potential difference between its ends is 1 volt. Clear? So in the next part we have we are going to solve some of the problems based on electric resistance. So before concluding the class, let me tell you one thing. Whatever the syllabus we are covering, please practice them on the same day itself. Don't keep anything pending. And in today's class, we have mainly focused on electric resistance. In the examination, they may ask, what is electric resistance? What are the factors on which electric resistance depends? Then what are the properties of electric resistance? This is one thing. Second important point is Ohm's law. They may ask you to state Ohm's law and also draw the circuit diagram to verify the Ohm's law, or to give the relationship between V and I. Another third important point is draw the graph of potential difference and electric current. So these are the possible questions to be asked in the examination. Okay, with this, let us stop the class. Let me continue in the next class. Thank you.